Alright, this time on Captain Castle Laboratory, we're going to actually cut open the mat from the Air Brite. If you remember part 1, I said when I get around to it, we're going to take the Air Brite, we're going to open it up and see what's inside, which should be coils of wire, and see if we can find why we have dead spots. I'm assuming because there's a spot right here where the coil is missing. And it's like that on all the mats. So I can understand the corners because it's a coil. You can't make sharp 90s. But there's a periodic here and there, there's dead spots. But we're going to open it up, take a look. I do it so you don't have to. So I just wanted to show you that it does work. For the most part. And that's what we're going to do today. So I'm going to unplug it. So. And then if you look closely at the edge of the mats, they have a seam. That's because those two mats stuck together. And the seam is pretty much right in the center. So let's take a razor knife and see about scoring it. Trying to do close to the edge so I know there's no coil here for me to damage if I slip or have a problem. There we go. You can see I got through the seam. Now let's see if I can continue. Remember, prop per knife is to always cut towards yourself. Right? No, you're not supposed to. You're supposed to cut away from yourself, but if you're controlled, you can be able to do it. So, this copper color, that is the coil I was talking about. So it's right up to the edge on the straights. This might take a little bit to get through it all since it's rather large. I'm trying not to go too deep. I do not want to damage the coil. There's also glue, of course, that's holding this. So let's continue down the side here. That works. So apparently you can just kind of use your finger to unzip it. That's nice. Yeah, that works way better than the knife. I'm sure if this had a warranty, I pretty much just voided it. But go. There's our circuitry. So we remove the housing. Now, let's see if we can get the top layer to come off the mat, which is got a decent amount of adhesive. Alright, so what do we got on here? We got inductors and a whole bunch of computer chips, transistors, resistors, capacitors, all sorts of fun stuff. And I said this is very similar to what charges your watch if you have a smartwatch as an example. It's a magnetic or a electro, well, it's almost a magnet, but it's a coil of electricity. If I remember right, the person that first invented it was Tesla, not the car company. I might have to use heat to get this to separate. Yeah, let's try a little heat. See if I can soften up this glue. There we go. But you can kind of see the glue right down in there. With all this flexing, let's see if I actually destroyed it or not. Probably should open one of the passive ones and not the active one. Huh, still works. I find it weird it doesn't work here since that's the connection. Or there where the connection is. Oh, see, we got a green idiot light. See? Look at that. Two of them. Side by side. Probably there to let them know when they were manufacturing it that the board tests okay. I'm sure they're probably not green or not on when they do a test at the factory before they put the cover on. Alright. Let's sit down and get a heat gun in here. Well, I'm making the plastic pliable, but it's not separating. I don't really want to make the plastic pliable. So, this is what I mean by the plastic. This bottom piece is thinner, and this was getting so hot it was distorting, while this upper piece is much thicker, and the thinner material absorbs the heat faster, so it was destroying the base, which is the part I don't want to destroy. might take a little bit of time. Whatever adhesive they use is really, really strong. And a flat scraper style X-Acto, a razor knife, is slowly separating it. And I mean slowly. So I'll have to say one thing. The adhesive they used, they did not skimp on. I don't think this was going to come apart anytime soon. At least not without a lot of persuasion. So instead of using a coil of wire, which is what I assumed, they're using a flat copper strip, which might actually have lots of coils within it. It might be so small I can't see it, or I can't see it through the coating on the top, because this strip does have a coating. Looks like right here in the middle there's a little less glue. Get a little leverage. There's still plenty of it though. Might just pause this so it's not an hour of me pulling on this until I get it apart, just to make the video slightly shorter and less boring. So I'm going to do that just to, again, make the video less boring. Because I'm sure for the next God knows how long, half hour, 40 minutes of me doing this, you probably don't want to sit here and watch, and I probably don't have enough topics to discuss while I'm doing this. So I shall return once I get this top layer off, so we can see looks like there's a coil here and a coil here, so it looks like a figure 8, which is weird that the center's dead, but I think I know why. It's because it needs the magnetic induction in the centers to light up the light. So if you're on the actual strip, there's no magnetic flux lines to turn on the light. So, but anyhow, bear with me. I'll be back in just a moment. For you, half a second or so. For me, I won't know until I'm done, and I'll let you know. I'll return just momentarily. All right, I'm back. It took me about a half an hour to get this to separate. I ended up heating it to help peel it, so it still works. Here's the cover, and let's get that out of the way. And there's your inside. So these are solder joints. So you got 1, 2, 3, 4, 5, 9, and 3, and that is what is given. So basically these are your coils. So underneath here are coils of wire. So, but it's still on. It's just dimmer. And with that front piece off, you still do get the loss because you don't have the magnetic flux lines coiling inside here. But if you lift it just a little bit, it turns on. Let's see, off, on, off, on. Whereas when you had this cover on here, it was still off. So I'm not sure. This is definitely shielding it. They did a decent job. I'm not going to lie. The glue they used is spectacular. But you can see they knew where their solder joints are going to be because they put indentations on the plastic. So, I mean, you got to give them props that they planned this out really well. So, how I got this apart is, it was upside down. I heated and pulled. So I just made until I could separate it, and then all the way to the end. So it's kind of a pain, but this is what the inside looks like. And the other ones probably have this, like this, just connected over here. So there's no, well, there's no circuit board because this is the active coil, and the other ones are the passive coils. So you could technically remove this and put this in something of your own doing, which allows you to now use the center as a light. Granted, it's not perfect, but you're still going to have some dead spots right down the center. Right down the center, off to the edge, off to the edge, right down the center. So when you're in the center line of here, you're going to get no power because you have no flux lines. So if you ever remember when you were in school and I talked about magnets or even the Earth's poles, you got the wire, the power coming out of the center and going around and coming back in. That's what this is doing, just on a much smaller scale. It's the same thing that charges your smartwatches. Like I was saying, same principle. It's using inductance to turn on the light. But you can integrate this into your own platform that may give you more use, because if you're just elevate it just the right height, you can still get the light and you'll have less dead zones. So when I'm touching it, the dead zone's much larger. But if it's elevated just a little bit, because there's no obstruction from that hard plastic, I can get the light farther out. But as soon as I cross the center line, it goes off. So that thick plastic, and this is plastic, this is a very rigid plastic, is obstructing some of the coil. Now I understand they say you can hold this so high up and it turns on, you know, and I know I'm that high up, turns off right about here, which is my knuckle. So I still get the same with the plastic. But it does interfere where the coils are connected to each other through the solder joints or the center line. So it exacerbates the center line of power loss. Making this have less dead zones would technically be impossible. You would have to make additional coils which could interfere in the corners or across the center line. You have overlapping coils, you're probably going to get some interference, and that would probably be a bad thing. You might lose your lights that way. But now that I see how this is done, and I'm not sure exactly what they use to adhere this copper to the backing, but it comes off. So why don't we remove it and see what it does when it's on a flat surface, because this is warped from the heat. I could probably stick it in the oven with something heavy front and back, like put it in a pie sheet, and probably get the flatness back, but I'm probably not going to ever use it. And whatever adhesive they use to hold the copper to the plastic and the copper to the base is not near as strong as what they use to hold the plastic to the base or the plastic to the plastic. If anything, I'd love to know what they use for an adhesive. I'm assuming it's some sort of spray adhesive, but they have good control to keep it, really good to the, they're right up to the edge. So whatever they used did a really good job. And this might even be the same adhesive. Maybe it's like a spray adhesive like I use for Gorilla, from Gorilla, where you spray one side and it's temporary, which is why I can peel this up. But if you spray both sides and stick it together, it's permanent. And, well, it's virtually impossible to remove it. I'm sure this has some prop warning like it causes cancer in California. A lot of adhesives do. I was doing fiberglassing today, so I have a raspy throat. Fiberglassing is very toxic if you've never done it. And even in a well-ventilated area, being outside with a fan to push the fumes away, it's really tough on the lungs. There we go. So I noticed that the adhesive here is shiny and the adhesive here is dull. So that's why I'm wondering if it's two different types of adhesive or if this was double back tape, a very thin layer of it on the back of this coil. But there's the back, kind of a dark color, tan, and your front is the copper color. Lights are on. So with this figure 8 or brick shape out, I'm wondering, I mean, you can see I'm holding it up. I'll do it where the light's visible. If you put this on terrain, I got some terrain right here. What I'm going to turn off some of these lights so it's a little easier to see the white light. Still center line, no power, but with terrain, if you were to incorporate this inside your terrain, this might come in handy. So it's at different levels. Of course, I wouldn't just have a droopy like this. You'd have, let's say something like this. But what this does is instead of having your mat flat and larger than your figure 8, you can contour it. You can mold it into your vignette or diorama or village display, which I'm not as good as. Some people out there, especially like Carl from Villages by Carl, his carvings are immaculate. Can you imagine him carving you a mountain? Or not, he wouldn't carve you one, but if you carved a mountain like he does, and you put this inside the mountain, where he does the dual layer mountain, where it's two pieces stuck together, so he can put a ring of lights or give you the depth effect. You have this in there, and then you have your house. So we'll do it sideways again. And then you have light sticking out of the mountain. And I'm going to grab one of the other passive mats. We're going to see if it still works. And technically it should work just fine, but here we go. Passive mat. I know it's working because we got strobing lights. The reason they're strobing is because the other passive mat is interfering with the main mat and it's overlapping. So and I think it's not working is because I have them overlapping. So they cannot overlap, which is what I anticipated would happen. But if I, again, I have it on terrain. I'm just holding it down because this is so heavy, I was trying to lift it. So the center line is still horrible. This one has more dead spots. And it might have more dead spots because it's passive or because it's bent. So let's remove the terrain. not sure why it dies in the center. I know it shows in their manual that you can put it in any configuration you want, as long as they're butted up against each other. Yeah, it works this way, so I think it's the magnetic flux lines don't reach all the way through. Slightly dimmer in the center. You can see if I go here, it's bright. Here it's dim. Center line. So the inside of this should be a complete figure 8. Let's take a look. Let's turn some lights back on so I can see. Apparently these, oh I see, similarly made but slightly different because there's no active unit. So we're gonna do like we did before, we're gonna slice it and then use our fingers hopefully to separate it. Yep, this is just a standard, it's the figure 8 without the power. So I'm going to move this one. Once it gets unplugged, I'm going to move this out of my way. I'm going to move the terrain out of my way. I'm going to move the box out of my way. To remove the base and top out of my way. Then I'm going to show you how I got it apart, just in case you want to do it yourself and destroy your own version. Now my heat gun I have set for 185 degrees heat pen, sorry, 185 degrees Celsius. So frickin' hot. It's a little cooler than I normally run it when I do stuff, but I don't want to damage this to the point where I damage the copper. So, this is how I did it. So the copper is attached to this stimpled side, not the other stimpled side, because it's thinner, so it absorbs the heat, like I was showing you on the other one where it distorted when I was trying to come in using the gap made from splitting it open. Very important to keep your heat moving, because if not, you'll just melt it and burn it. You can go slower or faster. Of course, the faster, the longer it'll take. Slower, the faster it'll be, but you can risk burning it. Now I see the plastic is starting to distort, which means it will start to separate. Yeah, this is why it took me so long, is because you can only do a couple inches at a time. If you go any more than that, by the time you start pulling it, it's cooled back down. When it cools back down, the glue readheres. Ask me how I know. Now, me leaving my fingers in here allows for me to see the plastics flexing. You can see how it's distorting. And I can tell the temperature by the pressure I put on it. I can feel that it's soft. I can also feel the fact that it's nice and toasty on my fingertips. So doing this, you do risk a burn. So be very careful if you decide to disassemble your Air Brite system. So I think for this part 2, it's just going to be disassembly. Part 3, maybe we'll figure out how to change the color of the lights. Or integrate the circuit, the inducted part of the lights into something else like a lamppost. Remember I said, be careful, it's hot. Now, there is a way to test the flexibility of your plastic. You can tap the tip, you can hear harder, softer, to see if it's pliable if you don't want to burn yourself. It's something that you can learn to distinguish the differences if you do it a lot. For my job, I do it quite often actually. I have to heat vinyl and PVC up a lot, and they teach you in the schools is how to use the end of the heat gun to tap your project to see if it's at its stage where it's pliable enough before you get into the I'm going to destroy it and burn it and melt it section. And what you're doing is you're feeling the vibration, and then you're also hearing the sound. But you can see, since I'm doing this one on camera, it's not as long as me trying to pull it apart using brute force, but it's still a very time-consuming process. And I am wondering, I have to try and make a platform. I'm wondering if I can integrate this into my platform that has contours, and if it'll work. The reason it came off easy is I was getting close to that big fat copper strip. So now that we have more than 50% of it, here's the last half. As far as the Air Brite system goes, well, it's not horrible. I don't like the dead zones, which a lot of people complain about. I understand why they're there now that I see the construction, and there's really no way to get around it. And I know why they use the thicker plastic after seeing the construction, because they use such a thin strip. It's so you don't break the strip by flexing this plastic. They don't want you doing what I'm doing, where I'm making almost a 90-degree bend in that copper coil. So, because the more you bend it, it's called work hardening. Basically, you make the material so rigid that it snaps. I'm sure you've wobbled a piece of metal or something back and forth a whole bunch, plastic even, until it breaks. I don't know if there's a way to change the composition of the plastic to give it better inductance. I don't know if Air Brite, the people who built this, designed it, took the time to study it, and maybe there's something that's a better material, but it's not cost effective. There's all sorts of things that go into this. It's almost there, though. Then we'll put the two coils next to each other as coils without the plastic in its way. And we'll see how it interacts. I'm sure when I won this, the people that sent it to me didn't envision me ripping this thing apart on camera. Because, technically they sent it to me, so I did win it. It was a drawing. But I'm sure they didn't expect their product to be dismantled, disassembled, examined. I'm going to try and heat up the entire remaining area so I can just hopefully peel it off in one fell swoop. Almost. Oh, so close. Nope. One spot. Now, this one though doesn't have the solder joints on the sides, so they just have it in the center. So they definitely have two different sets of molds for it. Now let's see if this will peel as easy as the other one did. So far so good. You got a hard spot right there. And I got a hard spot right here. And that could be the glue. That could be the fact that I got this thing hot and it changed the composition. Yeah, it's all stiff. There we go. Yeah, the spray glue apparently got onto the edge. This is shiny and this is dull. And I'm sure that's what's happening over on these two sides too. Yep. There we go. Not quite flat because of bending it and heating it, but again, if you stick something on top of this, it should be fine. So good green lights. There we go. And off. Down the center line. And now it's the center of both coils. So instead of being the center of one coil, because it's doing the inductance, it's now the center of the two coils since they're side by side. So center, off, off. Would you stop getting caught on me? There we go. Center, center, off. So this is what the inside of your Air Brite looks like for your active and your passive. The other passive is going to look the same. The slight differences besides your active circuit board is they have a solder connection on the... Why did the camera go all weird? Oh, it's because of the light. It just tried to focus on the light as showed a flower picture outdoors. So anyway, so you have a solder joint here as well as here, whereas you just have it here on this one. Why do you keep going out of focus? Anyway, now if you overlap them, you do encounter that, uh-oh, red light, green light. That's, so it's getting a feedback loop and it disables the system, which is why they were flashing. Okay, that's why they were flashing in the box. That's what I figured. When the two are on top of each other, frickin' camera. Focus. There we go. So when the two are on top of each other, it interferes. The magnetic induction interferes and causes the coils in there to have a problem. And when they're not overlapping each other, we get light. Oh, need to win a lottery so I can get a much better camera system. That's besides the point. But at least now you know what's inside your Air Brite system. You don't have to rip yours apart unless you want to try and contour it into a terrain. Like I was showing you. It may not be worth it. And I don't know if this can do a 90-degree bend, but let's find out with the one that's not cut open yet. So, let's see. It works. So if I do a 90, it won't work. It'll got the red light of death. Let's remove this guy out of my way. All in the name of science. So we'll do a 90-degree bend unless your edges of your coils overlap. So it does have a safety feature, which is nice. I just don't want the camera to keep going out of focus. I'm not sure what it's doing. So this will conclude the second part of the Air Brite system, what your inside looks like. Big copper coils. Like I was saying in the first video, I was expecting strands that were held together with an epoxy, maybe. I didn't expect it to be a printed coil on like circuit board material. So that was close. This probably works better. It's probably cheaper to manufacture and a little bit more rugged because of the flexibility. Because these boards, I know they tell you not to, but these boards do have distortion. So you can flex them. You're not supposed to, but you can. And that's because you can break it or sever, especially where they're soldered. So, like I said, taking it apart, seeing how they made it, I can understand why there's dead spots. Same reason I figured the reason the dead spots were in the corners is because they didn't have this. Oh my gosh. What is going on with this camera? Focus. There you go. So I figured they had a problem with the corners being too shallow, meaning they were curved more like this. It's not that, it's that you're hitting the center line where there's no... Let me put the lights on and we'll quit doing what it's doing. I think it's because it's getting reflection off of the light that's over there, reflecting up, and then of course this has got light, which is giving it a problem with its balance. So I figured the corners had too much of a sweep, they weren't as sharp, and that was the problem. And the problem is the center line. When you get to the center line, you use those magnetic induction coils. But when you're off of center line, the lights turn on. So, and you can see, as the white plastic obscures it, that it has two idiot lights, and the one turns off and flashes, and the other one turns red when there's a problem, when you're overlapping and you're getting inductive interference. Because your inductions are these two things right here. These are coils. And so are these. So you got 4. And that's what's helping with your connection. It's just part of the entire circuitry. So it's not horrible. I actually can appreciate their design a little more now that I've opened it up. And I'm really thinking in a future test, not necessarily the next one, of trying this on terrain, incorporating it into the terrain so the terrain's not flat, because this, as you can see, flexes, and you can see that when I overlap the coil, it triggers the system to go into trip status. So, but there we go. So for part 2, the disassembly of the unit, both passive and active, you can see how it looks, see what it does. You see it has idiot lights to inform you, which if you wanted to see those, you could just pop this apart. It's literally just held together with clips. You got a couple of clips all the way around, and then alignment pins, and bam. And it probably helps by actually. So you could pop this off at any point to see your colored lights there. Yeah. So that pretty much does it for this one. On the next one, we'll take one of these apart, maybe the big one, so there's more surface area to play with, because you can kind of see the coil when the light hits it just right. I'll do a pointy thing here. There's concentric rings. There you go. You can kind of see the rings there. That's what picks up this. Also, if we take one of these apart and we don't damage those concentric rings, we can test the power it's generating, because most white LEDs, require 3 volts to 5 volts to run. So am I inducing 3 to 5 volts of power in here, or are they running a different kind of LED, or do they have a little booster in here to increase the voltage? Don't know. I don't think I have an induction reader here in my drawer of stuff. What's this one got? I don't think it's going to pick up any amperage. Yeah. I don't have my my good meters with me because I use those for work, but I wasn't sure if my non-contact voltage would pick up anything, or if I could put on a some sort of induction to see what it could pick up. It doesn't matter. We'll work on these on the next one. So that'll conclude this one. Any questions, comments, put them below. Hopefully this gives you a better understanding what's inside your big white mats from Air Brite, as far as why you have dead spots. And if you want to do what I did, you can tear them apart, incorporate them into terrain, because the plastic being denser is going to reduce some of the magnetic flux lines, where your styrofoam probably won't. Just for giggles. Got a styrofoam head here. What is this? It's too, yeah, it's on, but it's really dim. Yeah, you can see. That's way too thick. It's not too bad. I don't think it's gonna. See, I don't think it'll go through two of them. I can try two of the smaller ones. I still get induction more powerful in the center, a little dimmer on the edges, but two of these together is 4 inches thick. So if you're doing a foam thing and you got like 2 inches of foam on it, it'll still work. I know they tell you it'll go through so much foam with the plastic, but you can tell it's slightly stronger, more intense without the plastic ring. So, but anyway, for the 13th time, this will conclude the video. Again, any questions, comments, concerns, put them below. If you're interested in the Air Brite system, I know I had a lot of comments on the first one. They didn't care for it after the quick review. But now that you see how the insides are, maybe still work for your village or a vignette, especially a vignette. Village is kind of more permanent structure unless you tear it up every end of season and reassemble it every beginning of season. In my case, it stays up all year round, so this would always be installed as a permanent structure. But other than that, there we go. That is the Air Brite system's internals for both the passive and active pads. You can see that it has a warning system where you have the induction issue when you overlap, and that might help you if you have it where you have a staggered set and you're overlapping and you can't figure out why you got strobing lights. This might assist you with that. Probably not, because I'm sure it's in their troubleshooting section. You probably already read it before you saw this video. But anyway, all until the next one, whether it be part 3 of this or an actual house repair. We'll see you then.